So say you found a skeleton. How would you tell it to die? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there, YouTube, the Dapper Dinosaur here. When last we left our historian of geology, he was talking about hypotheses for the formation of the moon, and was listing all the ones that are least likely. Today, he's going to get to the one that's most likely.
And there are serious theoretical problems with it. And so those ideas have been discarded. But there's one other daughter theory, and that is the giant impact theory. And the idea here is that there was an object about the size of Mars floating through the solar system. It slammed into the Earth, broke off a huge chunk of material, and that all got together and became the moon. Nobody ever saw that happen. Nobody ever did a scientific lab experiment.
This is the dominant hypothesis today. It is consistent with a number of lines of evidence, such as it retrodicts the lack of volatiles on the moon, it explains the moon's rather small core, and it is consistent with physical modeling of the objects involved both on paper and in simulations on computers. Time will tell if further predictions of this hypothesis are confirmed, and perhaps it can be raised to the level of a theory.
They're speculating about the unobserved past to explain the moon that we see in the present.
Yes, but science isn't just speculating. It is testing the speculation and throwing out ideas that don't fit the data. That's the important part that makes it science. It's what makes creationism not science. Because creationists don't and haven't thrown out their ideas now that they are known to not even remotely fit the data.
Well, in 2003, Discover magazine had an article, "Where did the moon come from?" Now that's exactly the question we're trying to answer. And they said, in fact, the story of the moon's origin is still slim on details. That's a scientific way of saying we really haven't got a clue.
No.
Actually, it's a non-scientific way to say that there is still a lot that we are unsure of, but that we have some pretty good idea of the basic picture of the formation of the moon. For example, if you said that the story of the murder of John Doe was slim on details, that may well mean you know the time of death and have a murder weapon. There's blood splatter consistent with your reconstruction of the crime, and you even have a suspect with his DNA at the scene and prints on the weapon. But exactly why he was killed, how he ended up where he was killed, etc. are still unclear. It's not exactly just guessing, and you have quite a few clues.
Experts are divided over whether the collision happened before or after the Earth had grown to its present size.
Yeah, that sounds like a detail, and not scientists having no clue. Do you really think that this is a serious flaw in the hypothesis? No hypothesis is without its questions.
Hey, I don't want a lot of detail. Could you just tell me, when that Mars-sized object hit the Earth, was the Earth the size it is now or a different size? They have no idea. Well, that was 2003, and you might think, well, that was 15 years ago. Science is advancing so rapidly, they surely know the origin of the moon now.
The pace of scientific advancement isn't even across all fields. There's no particular reason why such a difficult question should have been resolved in 15 years. But then, it also could have been.
Well, they didn't in 2012. In phys.org, new research provokes more questions about the origin of the moon.
Were they questions about the size of the Earth? You didn't say. But anyway, new research is supposed to raise new questions. Science is about the questions. The answers to any question should make you ask even more questions than were answered before.
It's beguiled watchers since before records were kept, and today still it fills poets with pensive musings and scientists with enchanting questions. Where did the moon come from? And how did it get there? Hopefully, new research will one day provide us with a definitive answer. Until that day, though, it seems we will all have to just keep musing.
Yeah, because like lots of things in science, we're not really all that confident yet. That's why there is no theory of lunar formation, just a number of hypotheses, one of which is currently the frontrunner. But then maybe we should just accept that your interpretation of a book is right, and stop looking into the matter. I'm sure that's what you're about to suggest.
Well, the evolutionists are musing. Creationists aren't, because we have the word of the Creator himself who told us when and how it came into existence.
Yup, I was right. You've got a book, so everyone should just shut up and stop trying to find answers based in physical evidence. I can't imagine how you think that that's a persuasive argument, but then you're not really trying to persuade anyone, are you? You're trying to bolster those who are already persuaded.
But there are problems with all those naturalistic theories. One is that we always see one side of the moon.
Okay, I'm gonna let you finish, but that's not really a problem.
And the reason that we do is because the moon is rotating on its axis at the same rate that it's going around the Earth. And scientists say it is tidally locked. There are many moons in the solar system that are tidally locked, but not all. And Mercury, Venus, Earth, and Mars are not tidally locked to the Earth.
That's true. No planet is tidally locked to Earth. I'm not even sure how that would be possible.
We can be really thankful for that, because if the Earth was tidally locked to the sun, it would be burning on one side and absolutely frozen on the other side.
It is good that the Earth isn't tidally locked to the sun, but it's not really lucky. Tidal locking depends on tidal forces. That is the difference in the strength of gravity between the near side of the body and the far side of the body and the object it's orbiting. These are extremely weak tidal forces between the Earth and the sun, but the tidal forces between the near side of the moon and the far side of the moon are much stronger. You see, the Earth pulls more strongly on the near side of the moon than the far side of the moon, so if we assume that at first the moon did rotate faster than it orbited, that difference would always tug on the near side of the moon trying to keep it in place, and it would slow down the rotation of the moon. But once the rotation speed matched the orbital period, the tidal forces would act to keep the periods in sync. Tidal locking is a well-understood process, and it is not a problem for any possible method of moon formation or capture. In fact, it is predicted by just basic Newtonian physics.
Well, there's another interesting fact about the moon, and that is that it produces every few years, somewhere on the Earth, a solar eclipse. And the moon slides right across our line of vision and completely covers the disk of the moon. The reason that it does this is because the moon is 400 times smaller than the sun, but it is 400 times closer to us than the sun. And scientists tell us that there are 181 moons in our solar system, and there's no other moon-planet relationship that produces a total solar eclipse.
Except that, scientists don't say that. Because, hey look, a total solar eclipse on Jupiter. And here's two happening at the same time on Saturn. Why be honest about the things you can see with a good telescope when instead you could lie blatantly about them and say Jesus made you do it? I mean, given the fact that you believe in Jesus, that would probably count as blasphemy.
That looks designed, not an accident.
What about that looks designed? Is it that currently the moon is almost at the maximum distance where it can still create a total solar eclipse? It wasn't always, it used to be closer, and so it was easier to have a total eclipse, and they used to be visible from a larger portion of the Earth's surface when they did happen. Nothing seems designed about happening to exist at a particular point in time.
We've put men on the moon. We've left equipment on the moon. We've brought back rocks from the moon. We know some things about how the moon operates, but they have no idea how the moon came into existence. So let's see what they know about the origin of the solar system. And as I've already indicated, they believe that the solar system came from a giant gas cloud that eventually evolved into the sun and then flattened out and produced the rings, and those rings became planets.
More or less, yes. And this is the result of gravity, which tends to collapse collections of matter, as well as the outworking of the conservation of angular momentum, which tends to flatten the orbit of objects orbiting a central mass over time. This is because the whole solar system has a particular angular momentum, which, being a vector, has a preferred direction and plane of spin. On average, interactions are more likely to align objects with this direction and plane than to move them out of it. As a result, any cloud of gas and dust with any angular momentum, which is all of them, will tend to collapse and form a rotating disk unless this is prevented. Really, in order to say that this can't happen, you need some pretty groundbreaking physics and attendant evidence to back it up. As it is, though, scientists have observed both star formation in nebulae and protoplanetary disks as predicted. So how about that? Scientists found evidence in the present about predictions about the past. It's almost like they're doing observational science.
And here in aerospaceweb.org, you can see that it's a simple 5-step process. But there are serious problems with that naturalistic theory. One is that the Earth is 70% covered with liquid water.
Honestly, this sounds like someone seeing a car crash in a ditch and seeing tire marks on the road, then remembering it snowed last night and telling the guy with him, "Gee, it looks like the driver lost traction on the ice and slid into the ditch." But then the guy says, "Yeah, but the problem is that his tires are made of rubber, so that couldn't have happened." Like, okay, you're not wrong that the Earth is mostly covered in a thin bit of water on top, but, water is one of the most common compounds in the universe. It covers a lot of objects in the solar system, and it even covers parts of Mars. The only thing special about Earth is that a lot of it is liquid, which, given Earth's temperature and air pressure, is exactly what it should be. I can't wait to hear why you think this is a problem.
It is the only known place in the universe where there's liquid water.
Whoops! Unless you count Enceladus, Mars, Europa, Ganymede, and possibly Ceres. And that's just in our solar system. Since liquid water is common here, and we know that other planetary systems exist, there's no reason to think that there isn't liquid water all over the place. Gee, it's almost like this historian of geology doesn't know what he's talking about when it comes to astronomy.
And liquid water is absolutely essential for biological life.
This might not be true. Ammonia has also been proposed as a viable solvent for carbon-based organic life. It has similar properties to water in terms of polarity, and while it has a lower viscosity and higher density than water, it may well still be sufficiently similar to dissolve the necessary chemicals. The other problem with it is that it is only liquid at very cold temperatures, temperatures where the reaction rate of organic chemistry is quite slow. But that just means that ammonia-based organisms would probably have a slow metabolism. That's not really a hard barrier. Also, liquid ammonia is known to exist on the surface of Saturn's moon Titan, so the existence of bodies with surface ammonia lakes isn't hypothetical. But of course, even if liquid water were absolutely vital to life, it's pretty common.
If the Earth was a little bit closer to the sun, our oceans would boil to steam. If it was a little bit farther from the sun, our oceans and lakes would freeze all the way to the bottom. We're just the right distance from the sun, kind of like Goldilocks.
In fact, depending on things like overall albedo, the Earth could be 5% closer and up to 2.5 times as far away without these problems. If you're willing to let the atmosphere vary, it's possible the ocean could be just fine inside the orbit of Venus. You know, if subsurface oceans are a possibility, then proximity to the sun isn't even a factor, provided we're not too close. What's perhaps more significant is Earth's magnetic field.
Then there's the fact that if we still count Pluto, which was demoted from being a planet in 2006, but is being reconsidered, but if we count Pluto and the 4 inner planets, they're all solid planets. But the 4 Jovian planets of Neptune, Saturn, Jupiter, and Uranus, they're gas giants with a liquid center. You can't land on those planets. That seems kind of odd if it's all the result of a slowly spinning gas cloud.
No.
Actually, that's a retrodiction of the nebular hypothesis. See, one of the things that you notice about the solar system is that there's a sort of density gradient where the denser planets are closer in and the less dense ones are farther out. This is because as the sun ignites its fusion in the core, it creates something called a solar wind. This is a pressure pushing out from the sun as a result of both EM radiation and actual particles of matter ejected in all directions from the sun. Of course, atoms and molecules are affected by this in a manner proportional to their mass and volume, that is, their density. So light things like helium and hydrogen get pushed out to the outer solar system more than dense things like silica, carbon, and iron. But if there is a large collection of mass, like Jupiter or Saturn, it can hold onto that hydrogen and helium because the solar wind is much weaker than their gravity.
The sun is 98% helium and hydrogen. The 3 planets closest to the sun are only 1% of those elements.
Yup, because those elements can't stay near the sun given the intense solar wind there.
They have different atmospheres. Mercury has almost no atmosphere. Mars is very thin atmosphere. Venus has a very dense, hot atmosphere. And Earth's atmosphere is just right for life.
Yes, they do have different atmospheres, which you'd expect given their different masses and distances from the sun, as well as their chemical composition. And Earth's atmosphere may be just right for life, but there's no way we can say that for sure, since our sample size for biospheres is 1. Until we find life somewhere other than Earth, there's no way to say that Earth is especially hospitable, since life adapted to Earth, not the other way around. It's possible that life would adapt just as well or better to other atmospheric conditions.
The planets have different orbits, different speeds of rotation, different tilts of the axis, different numbers of rings or moons. Some planets have both rings and moons, and different atmospheres. In fact, the more they send out space probes, the more they're surprised by what they find.
Are you going to tell us why you're implying that the nebular hypothesis predicts that all planets be essentially identical in terms of physical characteristics? Because as far as I know, it does not predict that.
And then if we still count Pluto, 7 of the 9 planets are rotating in the same direction that they're going around the Earth, around the Sun. But Venus and Pluto are rotating backwards compared to the direction they're going around the Sun.
In fact, Pluto's rotational inclination is a bit over 120 degrees, which means that it rotates in the same direction as it orbits. So once again, you're just flat out wrong about something. But keep going.
Jupiter, Saturn, and Neptune have moons going in opposite directions around the planet. Most of the planets have a tilt of an axis which is roughly perpendicular to their path around the Sun, but Uranus and Pluto are rotating on their sides.
Are you even going to try to make an argument based on this, or are you just going to mention that a few bodies are unusual in the solar system and then pretend that the bare fact that this is true is an argument against the nebular hypothesis?
In a textbook on astrophysics back in 1987, in the chapter on the solar system, we read, "Our brief survey has revealed the structure and content of the solar system." That's just telling us what's there. We can successfully, but the story's not closed. We can successfully interpret many of the observed features, such as the sources of meteorites. However, a plethora, that's a large number, of unanswered questions remain concerning the origin of these features. These unresolved questions prompt tentative answers, which they discussed in Chapter 7. Well, that was 1987. And you might say again, well, that was 30 years ago. Surely they know the origin of the solar system now. Well, they didn't in 2009. Newsweek magazine, or New Scientist magazine, had a cover story. The unknown solar system, the 6 greatest mysteries in our cosmic backyard. What were those 6 greatest mysteries? Well, they tell us in the article. The first one is, how did the solar system form?
The solar system is a product of gravity, and while the exact details are still up for debate, the basics of the nebular hypothesis are quite well supported.
Why are the sun and the moon the same size in the sky?
Because we're alive now, and not at some other time.
Is there a planet X?
I don't know, maybe, but that's not really a question that has much bearing on the age of the solar system or how it was formed.
Where did comets come from?
They probably formed in situ in the Kuiper Belt and Oort cloud.
Is the solar system unique? How will it end?
It's unique in that no other planetary system is likely an exact duplicate of it, but it's also not particularly unusual among the planetary systems we've discovered, and it will end when the sun explodes in about 4 billion or so years.
These are enduring mysteries to the evolutionists. And you open up the article, and they've got this big full-page picture showing you, again, that it's just a 5-step process for the origin of the solar system. But it's always good to read the fine print, not just look at the pictures. And up at the top it says, we think we know, not we know, we think we know the story of the solar system, but only comparison with other systems can tell us if that story is universal.
First, that level of caution is good science. Science can't ever be sure how something works or happened. Certainty in empirical matters is just not available to us. We are with more and more other planetary systems, and it seems that, the nebular hypothesis is the way it works.
Watch what they just did. They just changed horses in the middle of the stream. They start out saying, we think we know the story, in other words, how the solar system came into existence, and then they switch to a different question. We're not sure whether that story is unique or not.
Those aren't entirely separate questions. If the Copernican principle holds, and Earth is not a privileged location in the universe, which so far it seems to, then the formation of other planetary systems are likely to be similar to the formation of our solar system.
Well, I don't want to know whether it's unique. I want to know whether the story is true. And they don't know.
If the story is unique, then there's a good chance that the story is not true. So they're related, because physics here is like physics out there. But that is where we're going to end today's episode. Please remember to hit the like button, as well as to comment, and if you're not already subscribed, please go ahead and do so.
Thanks for watching, but before you go, I'd like to take a minute to thank my patrons, especially my $20 patrons. Bent Hovind, Ian Chen, Bob Knob, The Evil Scotsman, Henry Hutanen, Chris Love, and Res Instance. My team over at Patreon are helping me make these videos, and I have tiers starting as low as $1 and going all the way up to $100. So if you'd like to help out the Dapper Dino channel and help make these videos better and possibly even more frequent, then why don't you head over there and check it out. If a recurring donation isn't right for you, but you'd still like to help out, I have a link to my Amazon wishlist in the description. I'm the Dapper Dinosaur.
So you found the skeleton. How would you tell people that this is you personally? How would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.